Assalamualaikum students, this is our iOS app development lecture number 10 and our topic is inheritance. So let's get started. So what is inheritance? A class can inherit methods, properties and other characteristics from another class. Means take one property of one thing to another property, or to extend one category to more than one categories into different categories. We will call this as inheritance. In classes, how we can use inheritance? We can inherit one or more classes from our one main class or our super class, and we can create subclasses from that superclass. When one class inherits from another, the inheriting class is known as a subclass, and the class it inherits from is known as superclass. Inheritance is a fundamental behavior that differentiates classes from other types in Swift. As we know that in other data types of Swift, there is no inheritance in that, like for example in structures or in other variables or any other functions, etc. Inheritance has a class has a quality that we can apply inheritance over there. So inheritance is very essential part in classes. We can create different classes from one main class and can initialize with different names and can modify the data of the superclass in our subclasses. So we can also call superclass as parent class and subclasses as child classes. In simple words, so what are the benefits of having classes? Classes in Swift can call and access methods, properties and subscripts belonging to their superclass. For example, when we inherit, for example from our main class, we inherit different subclasses. So that subclasses can use the properties, methods and subscripts of the superclass, and can also modify that functions, but they can modify the function inside its own class but not in the superclass. Superclass will be remain as it is. Classes can also add property observers to inherit properties in order to be notified when the value of a property changes. Property observers can be added to any property regardless of whether it was originally defined as a stored or computed property. Is like a blueprint, and these properties will be used in that vehicles, right? This is like a blueprint, and its other subclasses will be a modified version of these vehicles. So instance of the class means object of the class. We will declare a new instance of our class vehicle. Like this, we will write let some vehicle is equals to vehicle. So here an object of the class vehicle is being created. By creating a new instance of the class, we can access the properties of the class like description or current speed or the function of the class. Like this, we will write print vehicle some vehicle dot description. This description is coming from our class vehicle. This is our super class. This is our super class, and this description is the property of our superclass, and this is our object, that is some vehicle. This object is assessing the property of the superclass with this dot operator, right? So what will it print? It will print vehicle traveling at 0.0 miles per hour. This 0.0 miles per hour is the speed of the vehicle, and this string is coming from the function that that coming from the property description. The vehicle class defines common characteristics for an arbitrary vehicle but is not much in use itself. To make it more useful, we will need to define to describe more specific kind of vehicles. Means this vehicle just has speed, current speed and description. But to modify our vehicle class, we will modify it through our subclasses. Means For example, we have different kind of vehicles. We have bicycles, we have bikes, cars, big cars, different types of cars. So that cars or that vehicles or bicycles have more properties, like their speed is more specified, their wheels, etc., or the engine or anything is more specified. So we can enhance or we can modify our vehicle class by creating its subclasses, and with help of these objects we can assess the properties of our class, superclass in our subclasses. So subclassing example: subclassing is the act of basing a new class on an existing class. Means if we have already created a class and we extend that class, then we are subclassing that class. The subclass inherit characteristics from the existing class, which you can then refine. We can also add new characteristics to the subclass. For example, we can write that our object let some resolution is equals to resolution. Resolution is our class. To indicate that a subclass is a superclass, we will write the subclass name before the superclass name, separated by a colon. So we have class some subclass dot some superclass. So we will name our subclass in this area, and we will write the superclass in this from which it is being inherited. So this is the syntax, this will be the curly braces, and the code written in this will be the subclass definition, right? Subclass definition, we will write different properties or methods of the subclass in this part. So example of subclass is class bicycle, and write this vehicle. So what it indicates? It indicates that it is the subclass and it is the base class. Base class or superclass or parent class, what do you want to name this class? This is the base. This is the base class, and this is the subclass, and we will write var has basket is equals to false. Mean our bicycle has no basket, right? So this is a new property that is added in this bicycle class. The new bicycle class automatically gains all the characteristics of vehicles. Means this class will have the properties of base class, that was speed, description, and its method or function will automatically be added to this one. So such as current speed and description properties and its make noise method. In addition to characteristics, it inherits the bicycle class define a new stored property, that is has basket. This is a new property that is added to the bicycle class that was not present in the vehicle class. By default, any new bicycle instance we create will not have a basket. We can set the has basket property to true for a particular bicycle. So by default, if we create any object, it will not have any basket, that because we have declared it false. But if we declare it true, then any object related to this bicycle will have a basket. So this subclass we have created this let bicycle is equals to bicycle. This is the object of our base class, and this is our base class, right? So we have created object of our base class. Bicycle dot has basket is equals to true. We have changed the value of bicycle property, that was has basket, from false to true. We have modified its value. So in this way we can also modify the inherited current speed property of a bicycle as well, because by default all the properties of the superclass has been added to the base class. So we will write bicycle, that is our object, bicycle dot current speed is equals to 15.0. That current speed is coming from our base class, but as we know it is being added to our subclass. This is subclass will be changed over there. So we will write print bicycle dot description. So this description is being modified from 2.2 to 15.0. So you can see that how we can create classes from superclasses, means subclasses from superclasses, and can create their objects and modify their properties as well with help of these objects. So this is a complete example of a superclass and a subclass. We have a superclass cricket and its function has print, right? Function print welcome to Swift 4 superclass. Then we have another class, that is class tennis, that is inherited from class cricket. So tennis is the subclass and cricket is the superclass. Then write this curly braces of the our class. Then I override function print welcome to Swift 4 subclass. This is the Swift 4 subclass. Then declare a variable, declare an object, that is this instance. Crick instant is equals to cricket, crick instant is equals to print. Access the function of the first class, right? This is accessing the function of this superclass. Then we will declare another object of tennis, that is tennis instant, that is the object of our subclass, right? And then print this tennis dot print, access the function of the subclass. So it will print welcome to Swift superclass and welcome to Swift subclass. So we can say that with help of these classes and superclasses we can manipulate the data, we can access data of one class to another class, we can even modify the data with help of creating different objects of these classes. So this is all for our today's lecture. Practice different examples on classes and superclasses for better understanding. Manipulate the data, change the properties and change the objects of these data for better understanding. If you have any question, you can ask in the live class or online class. So before that, make sure to try a few examples on classes, superclasses and structures. So before ending the lecture, I will give an overview of the reference type calling in classes. As we know that classes are reference type calling. So first of all, we have declared a object that was person2, and here we have a name Steve and age. We have created this person class in our previous lecture that has two properties, that was name and age. So we are initializing name as Steve, initializing age at 56. Now we have created our second object, that is person3, and we have initialized it to person2, means data of person2 is equals to data of person3, means this person3 have names Steve and age 56. These two have same data, but I want to modify the age of person3, that is from 56 to 35. So I will write person3 dot age is equals to 35. So this 56 is override to 35. We will write person2 dot age and person3 dot age. So the expected result is person2 age is 56 and person3 age is 35, but it will print 35 for both. So here it is a question that why it printed 35 in both the cases instead of 56. So as we know that classes are reference type of calling, means that when we are initializing this person2 to person3, we are initializing the data stored or the memory stored. For example, the memory space of person2 is equal to memory space of person3. So if I manipulate the data that is stored on that specific memory, as both data are saved on the same memory, it will change this memory as well. So if I make any changes in person3, will automatically change person2 data as well, because it is reference type of calling. Previously in structures it was value type of calling, so if we modify the data of only one thing will be changed, but here whole data is changing because we have declared that person 2 is equals to person 3, means these both data addresses are same, they are stored on this same memory. So if changing uh, anything in one memory will change the other automatically. So that's all for today's lecture.